We will take a closer look into these types when we use them, but now we've seen all the scalar types, so let's move to the compound types. And as we've said before, compound types, they can group multiple values in one type, and Rust has two primitive compound types. We have tuples and we have arrays. And what we see here can be seen as tuples. We have some values inside, and these values, they have different data types. And a tuple is a general way of grouping together a number of values with a variety of types into one compound type. And tuples, they have a fixed length, so once they are declared, they cannot grow or shrink in size. We can create a tuple by writing a comma-separated list of values inside parentheses. And each position in the tuple has a type, and the types of the different values in the tuple don't have to be the same. So here, for example, we are creating a tuple, and we are calling this, the name of this variable is tuple, and we have here parentheses. This tuple, first type will be integer 32, signed, float 64, and unsigned integer with 8 bits, and then we are binding these values 500 to the integer 32 type, 6.4 is the floating 64 type, and 1 is the unsigned 8 type, and we can access them through this tuple variable here. And it binds the entire tuple because a tuple is considered a single compound elements. So how do we get the individual values of a tuple? For that, we can use pattern matching to destructure a tuple value, for example, like this. So here we are creating our tuple variable, and here we are now destructuring this tuple, and each value will be assigned now to these names here. When we do, first we define this tuple, and then we destructure, use pattern matching. We're passing this tuple, so this 500, 6.4 and 1 are here. So 500 goes to x, 6.4 goes to y, and 1 goes to z. So when we print this, the value of y is 6.4. This is what we are having here. We're printing that the value of y is 6.4, and this is how we got the individual values of this tuple here. This program first creates a tuple, binds it to the variable tuple, then it uses a pattern with let to make this tuple, to take this tuple and turn into these separate values x, y, and z. And this is called destructuring because it breaks the single tuple into 3 parts. And then finally it's printing like I said before. There is another way how we can access a tuple element directly, and it's by using a period followed by the index of the value we want to use. So for example, now we are here declaring this tuple x. We are binding these values here to this variable. So it's a compound. We'll have all these values with these types here. But then we can, for example, get the 500. So we use the keyword let. This is another variable name. And then we have x dot 0. That means that we'll take the index 0 of this tuple, which is 500, and then it will bind this 500 to this name 500. The same to 6.4 and the same for 1. So we see that we can use the dot followed by the index to access this tuple elements directly. We've seen tuples, and another compound type is the array type. So this is another way how we can have a collection of multiple values, but unlike the tuple, every element of an array must be the same type. All arrays in Rust, they have a fixed length, and this can be different from some other programming languages. We write values in an array as a comma-separated list inside square brackets. So here, let the variable with name a be binded to this array. We have square brackets and then elements separated by comma. Arrays are very useful when you want your data allocated on the stack rather than on the heap. We will talk more about stack and heap later on. And apart from using it when you want your data to be allocated on the stack, when you also want to ensure that you always have a fixed number of elements, an array can also be very useful. So we mentioned that all the elements of an array needs to have the same type. And here, for example, we are declaring an array with let a, so the variable name a that will store our values. Then here we have the type and the number of elements, and then we are passing this list of elements. So here sin32 is the type of each element, and after the semicolon here the number 5 indicates that the array contains 5 elements. Another way to initialize an array that contains the same value for each element, we can specify the initial value followed by a semicolon and then the length of the array. So let a equals to 3 semicolon 5. That means that the array named a will contain 5 elements, and all these elements will be set to the value 3. And this is the equivalent of doing this here. How do we access array elements? So an array is a single chunk of memory. So an array is a single chunk of memory of a known fixed size that can be allocated on the stack. And we can access elements of an array using indexing like this, for example. So here we are declaring our array and we want to take the first element, so we use indexing in between square brackets. So we are taking the index 0, which is 1, so this is the first, the second is with index 1, and then second will be this 2, and so on and so forth. If you try to access an element of an array that is past the end of an array, this will result, for example, in a runtime error at the point of valid value in the indexing operation. This was a general overview of data types in Rust. We talked about scalar data types, we talked about compound data types. So scalar takes a single value, compound they have multiple values, and we talked about integer types that they can be signed and unsigned. We talked about floating point numbers that can be float 32 and float 64. We talked about boolean that can be true or false. We talked about character, that they are used for characters and they can take Unicode scalar values. Then on the compound types, we talk about a tuple, that are collection grouping together a number of values with different types. And we talked about arrays. In arrays, they have collection of multiple values that they must have the same type, and both of them, both the tuple and the array, they have fixed length in Rust, so they cannot shrink and they cannot grow. And we'll talk a bit more about tuples in our next time.